Welcome to Homework Lib.
So over here we're told that the pH of a solution determines the form of an amino acid. In this case, we want to determine which condition corresponds to each given structure of phenylalanine. So phenylalanine is going to be the following amino acid. We're going to have a benzene ring over here, and the corresponding compound would get the NH2 on this position and our corresponding carboxylic acid. So what we want to know of phenylalanine is going to be the corresponding pKa's for each of the groups. For the carboxylic acid group, we're going to have a pKa equal to 2.2. For the amino group, the pKa is going to be equal to 9.31. So the different configurations that we're going to be able to have are going to be the following. For pH lower than 2.2, the structure of phenylalanine is going to be the following. I'm going to omit the stereochemistry in this case. We're going to have a protonated amino group and a protonated carboxylic acid. Next up, for pH in a range from 2.2, approximately, well, a little bit higher than 2.2, all the way to 9.31, to the second pK, the structure of phenylalanine is going to be our phenyl ring, Actually, over here, sorry about that. I kind of omitted a carbon atom while drawing this structure. I just realized it's like this. So now in this case, we're going to have a deprotonated carboxylic acid, but the amino group is still going to be protonated. So this is going to be the sweeter ionic form. This is going to be the form that we're going to find this amino acid under physiological conditions, and at pH larger than 9.31, the structure of phenylalanine is going to be our benzene ring. Now the amino group is not going to be protonated, and we're going to have a deprotonated carboxylic acid. So these are going to be the three ways that we're going to be able to find phenylalanine. One is going to be positively charged at very acidic pH, at pH lower than 2.2. One is going to be the sweeter ionic form at pHs in a range from 2.2 all the way to 9.31. This is going to be the most abundant form. And finally, the one at a pH larger than 9.31. Remember always that when the pH is equal to the value of the pK, we're going to have 50% of the protonated and 50% of the deprotonated form corresponding to that value of pK, just as a comment for that. So these limits are not going to be as strict. So for example, the most abundant way would be actually from, let's say, 2.7 to 8.8, something like that. And in this case, of course, lower than 2.2 is already going to be way too acidic, just to ensure that those are actually the most abundant forms. But with that, it would be all. Thank you very much and have a good one.